I'm Alistair Edwardes, and I'm going to talk about the context of this of the work, and so a little bit about what the Data Science Campus at the Office for National Statistics does, before handing over to Sonia, who's going to really go into the details of one of our particular projects. So in the public sector, we need to be able to make effective decisions around how to distribute and manage public goods, and we need to do that in ways that are cost effective. And so in order to do that, we need to be making the best use of technologies, if you like, for the digital and the data age. So that means new data sources, new methods, new tools, improved ways of working. The Data Science Campus has been really sort of set up to enable the UK government to do that. And we do that in two ways. We help build skills and capabilities amongst analysts and data professionals in government. And we also develop research that demonstrates kind of opportunities of data science and helps provide tools that can catalyze others to use these kinds of techniques. I'm going to talk a little bit about sort of the three broad areas that we kind of work in that vein, and particularly looking at sort of some examples of campus research that are spatial. So the first area that we work on is really about improving and enhancing statistical output. So of course, as part of the National Statistics Institute, the ONS, one of our important roles is to investigate how data science can deliver better statistical outputs and therefore make better decisions. This might be, for instance, through disaggregating data, so just spatially disaggregating data. It might be through making more accurate statistics. So these are two examples of that sort of project. So in the first, we've been improving how we estimate natural capital for our national accounts, and particularly the natural capital that's contained by people's residential gardens. So sort of the green space contained by their gardens. And previously, we used to just use the kind of the cartographic almost footprint of a building plot. And then deduct where the house was, and I just assume everything was green space and therefore counted as natural capital. But here we've looked to improve that by using aerial imagery that we can sort of decompose the composition of the garden, so we can kind of remove aspects like paving and decking from that estimate. The second example is really taking a new novel data source but applying quality assurance to that to consider how it's essentially its fitness for purpose. So here we've been using data on a global data set that measures surface water and how that changes over time. It's a very powerful data set, and one which we need to fill a data gap with our sustainable development goal reporting. But what we wanted to do is we want to assess from that global level, so how appropriate it is for national reporting by comparing it, for instance, to other national sources and looking at various aspects. So we've been using the Code of Practice for Statistics within the ONS, but adapting that to think of these new novel big data sources. The next sort of project that we work on is perhaps more sort of conventional, and that's really developing new outputs, new products, new insights from novel data sources, and making these accessible to others. So these are two examples where we've used actually essentially different types of imagery of streets. So in the first, we've used open data from traffic cameras that are found across the country in the UK, and then we've applied deep learning to identify vehicles and pedestrians. And this has been really valuable in order to understand the sort of business of streets, particularly during this pandemic, and how that's been changing over time. And the other example is again looking at natural capital, but this time it's looking at generating natural capital, new statistical natural capital of street trees, if you like, and using street view data that's segmented to identify vegetation. And the final way that we work to sort of help make to help government is to help it be more efficient, and particularly through automation. And one of the ways that we've been doing this, one of the spatial ways we've been doing this, is in terms of sort of improving analytical pipelines that can help produce routine analysis or routine mapping more effectively, and using a single set of tools. And so we call this RAP for Maps as one example. So it's bringing geospatial into analytical pipelines for all sorts of analysts that we have in government. Also been looking at ways to bring tooling that might not exist in those pipelines, like network analysis, so that people can do more involved spatial analysis. And also been developing tools from the cloud-based tools that can help expose models and processes to people for building those into networks. So that's what I was going to talk about in terms of the context and the campus's work. And now I'm going to hand over to Sonia Williams, who's going to talk about a specific project about using machine learning to predict energy efficiency.
Hi, thanks, Alistair. If you want to move on to the next slide, that'd be great. Thanks. Yeah, so just wanted to explain a little bit of the motivation for why we were looking at this particular project around energy efficiency. So as with many of the other government departments and devolved administrations in the UK, there's some really ambitious targets around net zero carbon emissions. So in Wales, which is the government department that we've been working with, they're set to have net zero carbon emissions by 2050, which is quite, it's a pretty ambitious target. There's, many reasons why this is a really good idea and a good target to have. And statistics from other government departments show that the emissions that come from our homes, so our residential homes, contribute to about 20% of the overall emissions of carbon dioxide. So it's really impossible to reduce that to net zero carbon without also addressing what's coming out of our homes. Next slide, please. Yeah, so the data source we have here is the energy efficiency data. So in the UK, whenever a person moves house, by selling their house or by renting, then a certificate has to be created which shows what the energy efficiency of the property is. So that's usually done through a survey, and they're valid for about 10 years. It's a really, really rich data source. It's got over 80 fields that covers information about the property characteristics, the utilities, whether they've got solar panels or other energy efficiency provisions, and then a little bit about the location. So this data can be downloaded from the Ministry of Housing, Communities and Local Government. It's available from 2008 up until the very recent. And next slide. Okay, so what's the problem if we have data on energy efficiency? Why are we trying to do anything? So because that data only comes from those particular user cases, so selling your house, renting, or if you were having an assessment before getting a green grant, then only about 53% of properties actually have a certificate. So that's, over half without a certificate. And also, there could be a bias in the people who you're not aware of living in inefficient houses. So you can see the profile for Wales there, where the average is around a band D, but you can also see that A, which is the highest efficiency, less than 1% of homes in Wales actually have that higher efficiency at the moment. So hence why I say this is a very ambitious target. Next slide, please. So for anyone who has ever seen the energy efficiency data before, they'll know that it's not the cleanest data. It's reasonable, but there's quite a lot you need to do. As with any data science projects, really start getting your hands dirty and just start, sorting a lot of those issues out. So for example, there were translations that were needed to bring everything into English. There were invalid postcodes. There were different sort of unit metrics for the way that they'd measured some of the thermal values. So there was really quite a few things that needed to be done before we could start doing any modelling with this. Then at the end of all that cleaning up, we've got a usable data set which covers things about the building's dimensions, the composition of the building, so what's the wall made of, what's the floor made of, what's the roof made of, information about the utilities, the region, and the transaction type, which is the purpose of the certificate. Next slide, please. Okay, so we started off by checking first, is it possible to predict this energy efficiency value if you only have the energy efficiency data? So if you're using that data set, is it possible to predict it? We tested out 3 different feature sets. So using data-driven approaches, so more statistical methods like CHAID and chi-squared to define how the variables should be grouped up. Domain-driven, so using more knowledge, so for example, grouping double glazing types together and triple glazing types together within the data. And then the last one was an exhaustive approach, so just throwing everything to the machine learning techniques and letting that decide where to split the data. So that should be a lot more predictive, but it will also take a lot more computation time. So there should be, if you can, yeah, thanks. And what we found was the exhaustive model does indeed predict the best. It gives a pretty reasonable prediction for what we're looking at. So that was the technique then that we would take forward. For anyone interested, this was using an XGBoost model. So next slide, please. Thanks. And that also gives us an importance of what the model considers each of the variables to contribute. So you can see the top 2 there, total floor area and floor height, are sort of dimensions of the building. And it considers that that gives them the most information. So I think it's fairly well known that larger houses are harder to heat, less efficient, whereas something like a flat, which might be more contained by other buildings too, tends to be a little bit more efficient. Next slide, please. So now that we have established what will predict that value for us, obviously where we don't have a certificate, we don't have that information. So we had to look for that information from other variables. So we started off by looking with those top 2 important ones, which is the total floor area, as an example. So we used building polygons from Ordnance Survey. So there's 2 examples there of buildings in Wales. You can see they look quite different. And from that, we were able to take the area of the polygon as a proxy for the total floor area, and the length also as an indicator of the total floor area. We also looked at the uniformity of the polygon, so considering here whether a less uniform polygon, like the one on the right-hand side there, might suggest that the property has been extended. It also probably indicates a lot more external wall as well, which is likely to have less efficiency. So you're probably looking at that and thinking, that's surely a block of flats. No one's house is that shape. And that's right, it will be a block of flats. So within each of the toids or the polygons that we have, there are multiple properties in some cases. So we have in the UK a unique property reference number associated with properties, and each building can have multiple of those. So we've had to divide in those cases by the number of EPRNs associated with each toid in order to get something more relevant to the actual property. It's not ideal, obviously. In some cases, they won't be all the same, and there will be corridors, but it's close enough for our purposes at this point. So you can see the correlations on the right-hand side between the proxy variables we're taking from the polygons and then the original variables. So the correlations are pretty reasonable on a univariate level. Next slide, please. Okay, so another thing we used polygons for was working out whether the property was detached or attached, so and whether it's a house or a flat. So you can see examples here. The left-hand side is a detached property, and the right-hand side is a semi-detached property. And the polygons gave us pretty reasonable estimates of the built form of that. So where the EPC data set said a property was detached, we got that right 87% of the time, which is not too bad. And the next slide, please. Okay, so we've also then taken into account other geographical features. So we've used information from the neighbours. So taking the lat long from a property, looking at finding its 5 nearest neighbours, and then taking an average of the efficiency score for their neighbours and inputting that into the model. So we used a k nearest neighbours to work out what the neighbours were based on the centroids of the polygons. We've also directly given the model the latitude and longitude so that it can learn itself about the spatial dependencies between different properties and the other examples that it's seen before. You couldn't put postcode in, of course, because it's not a numerical variable that can be put in, but latitude and longitude gives us an alternative to that. And then we've also used from the census output areas features like the index of multiple deprivation. Previous studies have shown a relationship between deprivation and inefficient properties, and also whether the property is in the national park or not, because that could indicate that they're not allowed to make changes to their property as much as other people would be. Next slide, please. So in addition, we were able to get data from a few other sources. So for example, Ordnance Survey also address-based data has building height, and you can kind of use when it enters the register as a proxy for age, although it didn't turn out to be a particularly good one. Land registry, you can get whether the certificate was created because the property was being sold. And then Rent Smart Wales told us what properties were privately rented. So there's no personal data, I should add, amongst all of this. There's no indication of the people that are living there. Next slide, please. Okay, so one of the once we've gathered all these new data sources, obviously the cleaning has to start all over again. And again, this was not a trivial step, because for anyone that's worked with trying to match different data sources when you've got an address before, you know that's not an easy task. Ideally, we would have this UPRN in all the data sets. That doesn't happen. So matching that UPRN to the addresses is a tricky step, which we then had to do for all of those to match them together. Not many of the data sets contain all of the data sets, all of the properties, but then that would be expected because the Rent Smart Wales doesn't contain anything other than privately rented properties. Next slide, please. Okay, so just a quick cross-check here between what proxies we've managed to find for each of the variables. So for the total floor area and the floor height, we've got stuff from the polygons, same for the built form and the property type. So these were in the order of importance. The transaction type, we've got some covered, but not all, and we've got information about the region. The things that were contained more in the text data, we're making a bit of assumption here that they will get picked up from knowing information about their neighbours, or from, say, trying to have something like the age, for example. Next slide, please. Okay, so unfortunately, this first stage of the project, it didn't work especially well without having all of the rich information that's contained in that text data, such as things like whether a wall is insulated or not. The proxies that we found weren't able to fill in those missing gaps. So we did look at then whether the ones that we felt were more direct proxies were adequate, and they were adequate for the more numeric ones that we had found. However, that categorical data was just wasn't quite missing from what we'd managed to find so far. Next slide, please. So, starting a new phase of this one, I'm going to be working more on with the Department for Business, Education and Industrial Strategy, who are interesting from the field poverty point of view. And it's back to kind of the drawing board, looking at data and trying to find some of that missing information. Still would like to find a proper measure of property age, which I think would be valuable. Yeah, there's many other different options we could look at, deriving things from aerial imagery about the roof type, for example. I know that's been tried in previous places before, but yeah, it's endless where you could start. Sometimes the trick is knowing where to stop. Next, I think that's it. Yep.
think we should make it flow.
Okay, I'm sorry, slight delay on the system there. So yeah, we've got lots of people asking questions here on the chat. The first question is from Fabio Galicia, who asked, did you find softer variables like population density or tenancy type correlated with higher or lower energy efficiency?
So we haven't looked at population density because the energy efficiency we're looking at is by property. So population density, we don't know how many people are in the house. We don't have information about that, so we haven't been able to look at the population density. And what was the other one? Sorry.
We had population density and tenancy type.
Tenancy type, yeah. So we weren't able to find that up other than for the privately rented ones. So we didn't know whether a property could be socially rented or not. So it definitely does have a much higher efficiency in socially rented properties, partly because of the laws around that. But yeah, that's definite. Definitely more efficient.
Right. Okay. A few more questions here. We have Kieran Devlin says, what was the deep learning model you mentioned? I don't know if you missed that. Or...
Okay, so the one I mentioned was a machine learning model, XGBoost. We did also look at using a neural network, but it didn't improve the performance any more than XGBoost did. Most likely because the relationship between the variables is linear anyway. So the neural network isn't really adding anything.
Okay, thank you for that question, Kieran. And then from Pierre Potgita, how much of the calculations and modelling are possible without survey data?
So if you consider the actual target variable here, the energy efficiency comes from a survey, none of it, unfortunately. But some of the inputs, majority of those are not survey data. In fact, none of them are survey data. The inputs up to the model, just the target itself comes from a survey.
Right. Sorry, Pierre just said for clarity, he meant ordnance surveying data. I've just... oh,
I see. So it's in the polygons, I assume that means. Sorry, the question was how much of it?
How much of the calculations and modelling are possible without the OS surveying data?
So really not very much in the model we had would be, because a lot of the proxy variables have come from those polygons and the OS survey data. Yeah.
Fantastic. Great. And then I have another question here from Stuart Norris. So he said, you mentioned deprivation is correlated with poor energy conservation. It would be fair to assume many of these people also rent privately. So would this be a barrier to improving energy efficiency, as private landlords may not be motivated to install energy conservation measures?
Yeah, so I think without bringing in a law which makes private landlords operate the same way as social landlords in terms of energy efficiency, then yes, that would be a difficult thing to change, because it doesn't benefit the landlord really. It's the tenant's bills and the tenant's living conditions.
Fantastic. Okay. Thank you, Sonia. Then we also have one question here from Nico de Graaf, who has asked, what do you think about incorporating spatial autocorrelation and GWR regression?
That one I don't know. I'd have to think about that one a bit more. Sorry.
Okay. Well, it'll be possible within the networking break or in the chat. I'm sure you can take up that conversation with Nico. Mm-hmm. Thanks everybody for all the questions and some really nice feedback in the chat. So everybody seems to have really enjoyed the content. So Alistair and Sonia, thank you so much for preparing it and joining us today.
Thank you.